Hi everyone, welcome back to our channel and VINAY Kumar Basics of Physics. This is the right place to learn physics. Dear students, in this video we are going to discuss about what are the applications of dimensional analysis. In what way we are going to use dimensional analysis and what are the limitations of dimensional analysis. So this is the topic in this video. First time if you are watching my channel, then go to the playlist. All the intermediate topics, Eamcet, Neet, all topics are available. So all concept oriented topics ఉన్నాయి. మీరు గురుకుల ప్రిపేర్ అవుతున్నా, స్కూల్ అసిస్టెంట్ ప్రిపేర్ అవుతున్నా, టెట్ ప్రిపేర్ అవుతున్నా, పీజీటీ ప్రిపేర్ అవుతున్నా, ఇంటర్మీడియట్ ఎంసెట్ ప్రిపేర్ అవుతున్నా, ఐపీ ప్రిపేర్ అవుతున్నా, మీకు ఖచ్చితంగా ఆ వీడియోస్ హెల్ప్ అవుతాయి. ప్లేలిస్ట్లో జూనియర్ ఇంటర్ ఫిజిక్స్, సీనియర్ ఇంటర్ ఫిజిక్స్ ఇట్లా ప్లేలిస్ట్ ఇచ్చుకుంటూ వచ్చాను. అవన్నీ మీకు హెల్ప్ అవుతాయి. ఒకవేళ ఫస్ట్ టైం మీరు నా ఛానల్ చూస్తున్నట్టయితే ఛానల్ సబ్స్క్రైబ్ చేసుకోండి, ఖచ్చితంగా హెల్ప్ అవుతుంది. ఓకేనా, లెట్స్ కమ్ టు ద పాయింట్. What are the applications of dimensional analysis? The first thing is dimensional analysis can be used to write the units of a physical quantity. To write the units of a physical quantity, we are going to use the dimensional analysis. And second thing, to write the dimensional formula and units for constants. For different type of constants and coefficients, we are going to write the dimensional formula. And third one, to convert the physical quantities from one system of units to the another. And fourth one, to check the given relation is right or wrong. The equation what it is given, that should be correct or not, we have to check that by using some dimensional analysis. And fifth one, and here to derive the relation between different physical quantities, we are going to use the dimensional analysis. So these are the main applications of dimensional analysis. That's why here now we can go for in detailed explanation. Look here now. First thing, what is applications of dimensional analysis? The first thing here, find the units of a physical quantity, to find the dimensions of physical constant or coefficients, and to convert the physical quantity from one system of units to the another, to check the accuracy of the given relation, and to derive the relation between the different physical quantities. So మనకి ఇచ్చినటువంటి ఫిజికల్ క్వాంటిటీ యూనిట్స్ రాయొచ్చు. సెకండ్ వన్, ఏవైతే కోఎఫిషియెంట్స్ కానీ ఫిజికల్ కాన్స్టెంట్స్ ఉన్నాయో వాటికి మనము డైమెన్షన్స్ రాయొచ్చు. అండ్ థర్డ్ వన్, టు కన్వర్ట్ ది ఫిజికల్ క్వాంటిటీ ఫ్రమ్ వన్ సిస్టమ్ ఆఫ్ యూనిట్స్ ది అనదర్, ఒక సిస్టమ్ నుంచి ఇంకో సిస్టమ్ మనం చేంజ్ చేయొచ్చు యూనిట్స్ని. అండ్ టు చెక్ ది యాక్యురసీ ఆఫ్ గివెన్ రిలేషన్, ఇచ్చిన రిలేషన్ కరెక్ట్ ఉందా లేదా, ఎంత యాక్యురేట్గా ఉందో మనం ఐడెంటిఫై చేయొచ్చు. అండ్ ఫిఫ్త్ వన్, టు డిరైవ్ ది రిలేషన్ బిట్వీన్ డిఫరెంట్ ఫిజికల్ క్వాంటిటీస్, డిఫరెంట్ ఫిజికల్ క్వాంటిటీస్ మధ్య ఏదైనా రిలేషన్స్ మనం డిరైవ్ చేయొచ్చు బై యూజింగ్ సమ్ డైమెన్షనల్ అనాలిసిస్. ఓకే, క్లియర్? నౌ we will discuss all these things very clearly with examples. Okay, let's go for that. See the first one, find the units of a physical quantity. How we can find out the units? So already in the previous video we discussed about the how we can derive the dimension formulas and how we can write the units of a physical quantity by using dimensional analysis. We clearly discussed that one. So again I am giving one more example for you. So for example, here there is one physical quantity, that is the volume. It is there, volume. So what we write here, length, breadth, height. So here what write, length L, breadth also we are taking fundamental quantity length only, and height also we can take L only. That's what right here, L cube is the dimension formula of volume. So here for length what it is, the unit is the meter. That's why here what right units are meter cube. Clear? In the same manner here we know work is equals to what, force into displacement, force into displacement. Clear? So now W is equals to F into S. What is F here? Force, M L T inverse 2, and length is what, L. Then what we can write, M L square T inverse 2, M L square T inverse 2. It is a dimension formula for work. Based on that, how we can write the unit? For mass, kg, for length, meter square, and time, second. So time t means here unit is second, and inverse 2 is there, that's why we can write inverse 2. So kg meter square second inverse 2, it is the unit, and that should be also called as here joule. Clear? And similarly we can go for density. What it is? Mass for volume. Mass for volume. So for mass, as this is the dimension of capital M, and volume is L cube. So m L inverse 3, m L inverse 3. Then what at here unit is mass kg, and length meter, meter inverse 3. So in this way, by using dimensional analysis, we can write the units for different physical quantities in the same manner. Clear? See the second one. To find the dimensions of physical constant or coefficients. Dimensional analysis can be used to find the dimensions of physical constants or coefficients. So this is also we discussed while we are writing the dimensional formulas. Here we know that E is equals to h nu, where what is h? Planck's constant. What it is? Planck's constant. So for that also we can write the dimensions by using dimensional analysis like this. Here what is the formula? E is equals to h nu, and h is what? E by nu. So what, right? H is equals to E by nu we can write. What is E here? Energy. Its dimension formula is what? M L square T inverse 2 by frequency is T inverse 1. Then what is here? M L square T inverse 2 plus 1. Then what it is? M L square T inverse 1. So this is the dimension formula of Planck's constant H, and dimensions are 1, 2, minus 1. Clear? So in this way we can write the dimensional formula for constants. This is the one example. Let's go for another example. So it is also there. F is equals to G into M1 M2 by R square. What is? Universal law of gravitation. According to that, what, right? G is equals to F into R square by M1 M2. Here what is F? Force. Its dimension formula is M L T inverse 2, and R distance, nothing but here L square by mass S capital M square. Then what is here? M inverse 2 L square L cube T inverse 2, and now it is M inverse 1 L cube T inverse 2. So this is the dimension formula for universal gravitational constant. In this way we can write the dimension formulas for different physical constants. Clear? Third one. To convert the physical quantity one system to another system. One physical quantity is there, for that some units are there. The unit should be going to be convert from one to the another system by using dimensional analysis. How it's possible? Let's see. Here some x, it is the one physical quantity. What is x? Is what? Physical quantity. Clear? Some let x is the physical quantity, and its dimension formula is m to the power of a, L to the power of b, and t to the power of c. M to the power of a, L to the power of b, t to the power of c. Now we want to change the units from one system to the another. So here in one system should be like this: m1 to the power of a, L1 to the power of b, and t1 to the power of c. So it is a dimension formula in one system of units, and it's the numerical value. And next, this is the another system that should be having some numerical values n2, and the dimension formula is going to be like this: m to the power of a, L to the power of b, and c. Then here we will convert from one to the another. So by using this relation only we are going to convert them. Clear? For example, here I am going to take that x is the now here force. X is what? Force, and its dimension formula is m L T inverse 2. M L T inverse 2. Now here I am going to write 1 Newton is equals to how many? That is the question here. 1 Newton is equals to how many dynes? So 1 Newton is equals to how many dynes? Here Newton is belongs to the SI and dynes belongs to CGS. So now we are going to convert the 1 Newton into number of dynes. That is, we are converting from SI to the CGS. So for that, here we can write like this: 1 Newton is equals to here 1 Newton is nothing but what it is here, mass kg, length what it is meter, and time is what, second inverse 2. Clear? 1 kg meter second inverse 2. Now simply here 1 kg means what, 1000 grams, and 1 meter is equals how many centimeters, 100 centimeters, and this is second inverse 2. Now here we can write 10 cube into 10 square gram centimeter second inverse 2. So now here gram centimeter second inverse 2, it is the unit is nothing but equals to dyne, that should be in CGS. So in this way we can convert from like this here. So 1 Newton is equals to 10 to the power 5 dynes. See the next example. G value is given 6.67 into 10 to the power minus 8 CGS units. We have to convert into the SI. That is the concept here. So by using this one, how we can convert that? How we can convert the G value from CGS to SI? Let's see here. So to do that one, first you have to know idea about the dimension formula of capital G. That is what, M inverse 1, L cube and T inverse 2. Clear? So that's why here in SI, what do you need here? kg inverse 1, meter cube, second inverse 2. In CGS, gram inverse, centimeter cube and second inverse 2. So when we have idea about all these things, the conversion is very simple. Clear? Again we are using same relation here. N1 is taken as here SI. This should be taken as SI and should be taken as CGS. Clear? So we want to find out the N1 value. So here what it is, the M1 to the power of minus 1 and L1 to the power of cube and T1 to the power of minus 2. Here N2 value is what, 6.67 into 10 to the power of minus 8. Clear? So M2 to the power of here minus 1, L to the power of 3 and T to the power of minus 2. Here we want to find out the N1 and you can take that's fine. This one here, N1 is equals what, 6.67 into 10 to the power of minus 8. Here M2 by M1 and all to the power of minus 1. Here L2 by L1 all cube. Simply we are bringing the side only. T2 by T1 all to the power of minus 2. So here N1 is here now 6.67 into 10 to the power of minus 8. M2 is what, CGS unit. CGS unit is what, mass, gram. So gram by, and M1 is kg. That's why we have to convert it into the grams. 1000 kg all to the power of minus 1. L2 centimeter and L1 is meter, that is equals to what, 100 centimeters all cube. And now here T2 second by second all to the power of minus 2. Here gram cancel, centimeter cancel. Then what we have? We have N1 is equals to here 6.67 into 10 to the power of minus 8 into 1 by 1000 means what? 10 to the power of minus 3. 10 to the power of minus 3 all to the power of minus 1. 1 by 1000 means what? 10 to the power of minus 3 all to the power of minus 1. Here 1 by 100, that means what? 10 to the power of minus 2. 10 to the power of minus 2 all cube into second over second means 1. 1 to the power of all to the power of minus 2. That means simply here it is 1. Then N1 is equals to here 6.67 into 10 to the power of minus 8 into 10 to the power of minus 3 minus 1, 10 cube into 10 to the power minus 6. Clear? So that is here N1 is now n1 is equals to here 6.67 into 10 to the power of minus 8 of, it is 10 cube and into the power of minus 6. 10 to the power of minus 6 plus 3, s minus 3. So it is minus 3. Then what do you hear? N1 value is here now 6.67 into 10 to the power of minus 11 kg meter second inverse. Kg inverse 1, meter cube second inverse 2. So that is the value of N1. So then what do you write here now? 6.67 into the power of minus 11 kg inverse meter cube second inverse 2 is equals to this one. 6.67 into the power of minus 8 gram inverse centimeter cube second inverse 2. Okay, so in this way we will convert the units from one system to the another system. Clear? The fourth one, what it is, we have to check whether the given equation is correct or not. So to check the accuracy of the given physical relation, so I will give one example here. Before going to that, you have to know idea about the principle of homogeneity. Principle of homogeneity. According to this, in any dimensional equation, for example, we are writing here now x is equals to some y plus z is there. Clear? So x is equals to y plus z, or x is, or y is equal to some a minus b, like this. We are having some equations. Here y, z, we are adding any other, here addition, subtraction. So you can take any arithmetic operation, then if it is in the same relation, then they have the same dimensional formulas. Clear? The physical quantities which are going to be added or subtracted, they must be have same dimensional formula. That is you have to remember. And second thing, in any equation, dimensions of the physical quantity which is on left side should be equals to the dimensions of the physical quantities on right side. So these two things you have to remember. Okay, principle of homogeneity prakaram, in any equation, the physical quantities which are going to be added or subtracted, ఏ physical quantities అయితే మనం యాడ్ చేస్తున్నామో సబ్ట్రాక్ట్ చేస్తున్నామో అవి ఒకే డైమెన్షన్ ఫార్ములా కలిగి ఉంటాయి, లేదా ఒకే డైమెన్షన్ ఫార్ములా కలిగి ఉన్న వాటిని మాత్రమే అడిషన్ కానీ సబ్ట్రాక్షన్ కానీ డివిజన్ కానీ మల్టిప్లికేషన్ కానీ చేసే అవకాశం ఉంది. అండ్ నెక్స్ట్ థింగ్, ఏవైతే మనం డైమెన్షన్ ఈక్వేషన్ రాస్తున్నామో ఆ డైమెన్షన్ ఈక్వేషన్లో మనకి లెఫ్ట్ సైడ్ ఉన్నటువంటి ఫిజికల్ క్వాంటిటీ యొక్క డైమెన్షన్ ఫార్ములా అనేది రైట్ సైడ్ ఉన్నటువంటి డైమెన్షన్ ఫార్ములాస్కి ఈక్వల్ కావాలి. అలా అయితేనే ద రిలేషన్ ఈజ్ కరెక్ట్. ఇన్ ఎనీ ఈక్వేషన్ ద డైమెన్షన్స్ ఆఫ్ ద ఫిజికల్ క్వాంటిటీస్ విచ్ ఆర్ ఇన్ ద LHS షుడ్ బి సేమ్ యాజ్ ఆన్ ద RHS. Then only the given equation is said to be correct. Clear? So now here x is equals to y plus z anamada. So now here I am giving one example. Now here centripetal force F is equals to mv square by r. This is the equation. F is equals to mv square by r. Here what is F? F is the force. Its dimension formula is what? ml t inverse 2. And now here what is m? Mass. Its dimension formula is what? Capital M. And now v is what? Velocity. Its dimension formula is what? LT inverse 1. And r is nothing but radius. That is what here dimension formula is L. Now we can substitute those in that equation. Let's check here what's happened. F is what? M L T inverse 2 is equals to M mass V L T inverse 1 whole square by L. Then what do you have? M L T inverse 2 is equals to here M L square T to the power of minus 2 by L. Then what you get here? M L square L to the power of minus 1 and T to the power of minus 2. Then what you get here? M L T inverse 2 is equals to here now M L inverse 1 and T inverse 2. So we are getting the plus 1. 2 minus 1 plus 1. Okay. Now he can observe here the dimension formula is same on both sides LHS and RHS. When it is we are reading like this, then only the given equation is correct. So here on LHS, mass dimension is what? 1. RHS also 1. Dimension of L is what here? 1. It is also 1. And T is -2, -2. So the dimensions of physical quantities are equal on both sides. Then only the given equation is correct. That's why it is the given equation is correct one. And in the same manner, we have another example we will see to check the accuracy of given physical relation. That is S is equals to UT plus of AD square. S is equals to UT plus of AD square. According to the principle of homogeneity, we can add the physical quantities which are having the same dimensional formula. That is you have to remember. According to the principle of homogeneity, we can add the quantities which are having the same dimensional formula. That is the first thing you have to remember. And the second thing is, in any equation, dimensions of concerned physical quantity must be have same dimensions on both sides, LHS and RHS. Clear? Principle of homogeneity ప్రకారం ఏదైనా ఒక ఫిజికల్ క్వాంటిటీ రిలేషన్లో మరి ఫిజికల్ రిలేషన్లో ఉన్నటువంటి అన్ని ఫిజికల్ క్వాంటిటీస్ కూడా ఒకే విధమైనటువంటి డైమెన్షన్ ఫార్ములా ఉంటేనే వాటిని మనం యాడ్ చేయడం కానీ సబ్ట్రాక్ట్ చేయడం కానీ జరుగుతుంది. ఫస్ట్ థింగ్. అండ్ సెకండ్ థింగ్ ఈజ్ వాట్, మనం ఒక ఫిజికల్ ఈక్వేషన్ రాసినప్పుడు ఆ ఈక్వేషన్లో ఎల్హెచ్ఎస్లో ఉన్నటువంటి ఫిజికల్ క్వాంటిటీ యొక్క డైమెన్షన్స్ అనేవి ఆర్హెచ్ఎస్ సైడ్ కూడా సేమ్ ఉండాలి. ఓకేనా? అది. సో నౌ హియర్ వాట్ ఈజ్ ఎస్? ఎస్ ఈజ్ ద displacement and its dimension is what? L. Now we can check this is the equation is right or wrong. ut, u into t, what is u? Velocity. Lt inverse 1, and what is t? Time. So then what it is? L into t to the power of minus 1 plus 1. Then what it is? L t to the power of 0. T to the power of 0 means what? T only, 0 only, 1. T to the power of 0 means 1. So it is what? L. And similarly here, of AT square, for this of there is no dimension formula. We can write for only AT square. LT inverse 2 is the dimension formula of A, and it is T means time T square. Then L into T to the power of minus 2 plus 2. Then L T to the power of 0, that is equals to what? L. So here both are having the same dimension formula. That's why here that is going to be like this here, L. So now here it can obey the principle of homogeneity. That's why this relation is correct one. Fifth one, to derive the relation between different physical quantities by using dimensional analysis. How it is possible? Let's see here. For example, time period of the simple pendulum is t is equals to 2 pi into under of L by G. We have to derive it. So this is the equation what we know. For that we have to derive the relation. For that you have to go for principle of homogeneity, and you have to take the equation should be like this. T to the power of T is proportional to the L to the power of A and G to the power of B. T is proportional to L to the power of A and G to the power of B, and we are using some constant, some K into L to the power of A and G to the power of B. Here constant, okay. And what is T here? Time. That's why its dimension formula is capital T. And for this one there is no dimension formula. And what is L? Length. That's why here we will take it is L, all to the power of A. And G is what? Acceleration due to gravity, L to the power of minus 2, it is B. Now according to the principle of homogeneity, dimensions of physical quantity on LHS equals to the RHS. Clear? So I am going to write like this one: m to the power of 0, L to the power of 0, and T. And now it is K into L to the power of A, and now it is L to the power of B, L to the power of B, and T to the power of minus 2B, T to the power of minus 2B. Clear? Now we can compare the dimensions of M and both sides, M and LT on both sides. So here for first m we have take. On LHS what is there? 0 is there, 0, and in this case also there is no m, that's why simply we are going to write 0. And now for L, dimensions of L on both sides, L to the power of 0, here L to the power of 0 is equals to here L to the power of A, L to the power of B, that means what? 0 is equals to A plus B. Now this is equation number 1. And now here comparison of dimensions of T on both sides. Here T is there, that means what? 1 is equals to here nothing is there, 0, plus here what is minus 2b is there, minus 2b is there. So 1 is equals to what? Minus 2b, and b is equals to what? Minus 1 by 2. B is equals to minus 1 by 2. Clear? Now substitute this b value in the equation number 1. If it is equation number 2, from equation number 1, what do you write here? 0 is equals to a plus b, and 0 is equals to a, b value is what? Minus half. When 0 is equals to a minus half, that means a is equals to 1 by 2. A value is what? 1 by 2. A is equals to 1 by 2. Now substitute these values in this one. What it is? T is equals to some k into L to the power of A value is what? 1 by 2, and G to the power of B value is what? Minus 1 by 2. Then what right here? T is equals to k into, we will write L by 2 by G to the power of 1 by 2. We will write T is equals to k into, and L by G whole to the power of 1 by 2 we can write. Then T is equals to k into, we will write this is L by G, under of L by G, and this k value is, it is 2 pi. Then what we get? Almost all same relation we are getting. So in this way we will derive the relation between different physical quantities. Clear? Let's see another example. See the second example. Derivation of E is equals to mg square. This is the equation we are going to derive. For that we have to go for assumption E is proportional to m to the power of A and c to the power of B, and we are going to sum h to the power of c. Here what is here? E is equal to some constant f into m to the power of A and c to the power of B, h to the power of c. Here what is E energy? Its dimension formula is m L square T inverse 2, and f is the constant, leave it. Here m is the mass, its dimension formula is capital M, and c is what? Velocity, its dimension formula is LT inverse 1. H is the Planck's constant, m L square T inverse 1. So these are dimension formulas, you have to substitute there. What is E? M L square T inverse 2 is equals to some constant f into, here m to the power of A s, now L to the power of minus 1 whole to the power of B, and m L square T inverse 1 whole to the power of C. Clear? Now substitute the power to the every individual quantity. M L square T inverse 2, f is equals to here m to the power of A and L to the power of B and T to the power of minus B. Now m to the power of C and L to the power of 2C and T to the power of minus C. Clear? Now comparison according to principle of homogeneity, the dimensions are on both sides should be equal. So now first we can compare the comparison of dimensions of m mass on both sides. So what is here? 1 is equals to A plus C. 1 is equals to A plus C. A and C. When bases are equal, we have to add the exponents. And next here, L, comparison of L. 2 is equals to B plus 2C. Equation number 2. 2 is equals to B plus 2C. And now comparison of T on both sides. Then what is minus 2 is equals to minus B plus C. minus b plus c. This equation number now 3. So we can take the equation number 2 and 3. From equation number 2 and 3 we can add them. 2 is equals to b plus 2c and minus 2 is equals to minus b plus c. Clear? Then what you get here? 0. This will cancel. Then 3c. So 3c is equals to 0. That means what? C is equals to 0. C is equals to 0. Substitute that c value in equation number 1. From equation number 1. Then what it is? 1 is equals to a plus 0. A is equals to 1. A is equals to 1. Clear? And in this equation, equation number 2, from equation number 2, what rate? 2 is equals to b plus c value is what? 0 into 0. Therefore 2 is equals to what? So b is equals to what? 2. B is equals to 2. Now substitute all these values in this equation. Clear? What it is? E is equals to some f into m to the power of a value is 1 and c to the power of b value is 2 and h to the power of 0. H to the power of 0 means what? 1. Then E is equals to f into mc square and f value is equals to 1. Then E is equals to mc square. E is equals to mc square. In this way we can derive the equations by using dimensional analysis. Now let's discuss about the demerits or limitations of dimensional analysis. What are the limitations of dimensional analysis? Dimensional analysis cannot be explained one specific dimensional formula for one physical quantity because here dimensional formula for different physical quantities. Clear? And next thing is dimensional analysis cannot be explained about the constants, proportionality constants what we are going to use in the derivation of physical quantities. We are using some constants. For that constants it was not dimensional analysis not given any information. And third one, in any relation if there are some trigonometric functions and some powers are there, then also it is very difficult to derive the equation by using the sine functions and power according to the dimensional analysis. It's very difficult. And fourth one, finally, up to now we discussed relation between the different physical quantities by using the base quantities mass, length, time only. It means that if any physical quantity have more than 3 or 4, then it is very difficult to establish the relation between different physical quantities. So these are the main demerits or limitations of the dimensional analysis. So on board it is there, look here once. If dimensions are given, physical quantity may not be unique as many physical quantities have the same dimension. So మనకి డైమెన్షన్స్ ఇచ్చినప్పుడు ఒక ఫిజికల్ క్వాంటిటీ అనేది మే నాట్ బి యూనిక్, సింగిల్ దానికి మాత్రమే లేదు, డిఫరెంట్ వాటికి కూడా సేమ్ డైమెన్షన్ ఫార్ములా ఉంది. ఫర్ ఎగ్జాంపుల్ ఇక్కడ విల్ రైట్ సమ్ డైమెన్షన్ ఫార్ములా ml square t inverse 2. So it is the dimension formula for work, energy, potential energy and kinetic energy. Clear? So that is the problem here for same dimension formula for different physical quantities. Okay, and next thing, numerical cannot be have no dimensions. Dimensional analysis not given any information about the proportionality constant like k. Manamu t is equals to 2 pi by omega, we are writing something, we are not discussing about the 2 pi, simply we are comparing the only dimensions of physical quantities only. So ఒక రిలేషన్ ఉన్నటువంటి కాన్స్టెంట్స్, ఫర్ ఎగ్జాంపుల్ kinetic energy is equals to what? Half mv square. సో మనం ఈ mv square రాస్తున్నాం కానీ హాఫ్ కి ఏమి రాయడం లేదు. దట్స్ వై హియర్ another demerit this is. And theory of dimensions cannot be applied to the derived formula containing the trigonometric functions. For example, displacement of a progressive wave is given by the relation y is equals to a sin omega t. Here y is the distance, displacement, and a is the amplitude. Then what about this one? S. And like this, n is equals to n naught into e to the power of minus lambda t. So law of decay. In that also here we are not able to explain all those things in power because we are e to the power it is there. సో అంటే ఈ ఫామ్లో ఉన్నటువంటి వాటికి మన డైమెన్షనల్ అనాలిసిస్ క్లియర్గా ఎక్స్ప్లెయిన్ చేయలేకపోయారు. దట్స్ వై ఇట్ ఇస్ అవర్ డిమెరిట్. అండ్ థియరీ ఆఫ్ డైమెన్షన్స్ కెనాట్ బి అప్లైడ్ టు ది డెరివేటివ్ ఫార్ములా కంటైనింగ్ ది more than three physical quantities. So anything should be explained like this only, MLT. We are mainly using the mass, length, time or the base quantity as a dimension formula for different physical quantities. While we are deriving the relation, మనం ఒక ఈక్వేషన్ కరెక్ట్ ఉందా చెక్ చేయాలన్నా, ఒక ఈక్వేషన్ రిలేషన్ డెరైవ్ చేయాలన్నా మనం మెయిన్ దీనే యూజ్ చేస్తున్నాం. అంతకంటే ఎక్కువ ఉన్నప్పుడు వాటి మధ్య వీఆర్ అనేబుల్ టు ఎస్టాబ్లిష్ ది రిలేషన్ బిట్వీన్ ద మోర్ క్వాంటిటీస్. సో దీస్ ఆర్ ద లిమిటేషన్స్ ఆఫ్ డైమెన్షనల్ అనాలిసిస్. Okay dear students, if you can understand this one, like, share, comment the video and share our channel to your friends. So then only my content will reach us to the more people. So do that particular help. Okay, thank you for watching.